Development of RTO types. First generation RTO incinerator is 2-tower type RTO, and with such configuration, organic waste gas that has not been completely decomposed is discharged in the valve switching process. So it is inefficient in terms of removing VOCs. This circumstance later gave rise to the emergence of Multi-Tower type RTO, which can effectively mitigate the problem of direct waste gas discharge seen in the 2-tower type RTO, thereby further improving the purification efficiency. To deal with increased air volume, however, Multi-Tower type RTO have to be equipped with larger valves. This leads to a higher leakage rate of valves, bulky equipment, and more energy consumption as a whole. Later, third-generation General Rotary RTO was designed. Such as RTO model effectively solves such problems as excessive pressure pulsation within the pipeline and gas mingling that is caused by valve switching. Unfortunately, due to its own structural design defects, gas mingling is prone to happen as there is a gap between the surface and the disc. During operation, the disc is prone to distortion owing to fatigue load. Meanwhile, the existence of friction resulted larger gap, which leads to waste gas leakage, and low efficiency in terms of removing VOCs. With the growing voice of the low-carbon economy, the fourth generation of products, single-cylinder multi-valve RTO, was invented as the situation requires. It features zero gas leakage, low pressure pulsation, simple structure, and small space, with a VOC removal efficiency of more than 99.4%. and thermal storage efficiency up to 95%. 2. Principle. The single-cylinder multi-valve RTO uses a multi-valve airflow switching mode featuring zero leakage to solve the problems of general rotary RTOs, including low efficiency of waste gas treatment caused by their own structure. So it deserves to be a kind of innovative equipment with ultra-high VOCs removal efficiency in the field of RTO. A multi-valve RTO is composed of 5 parts: main pipe, switching valve, distribution chamber, thermal storage layer, and combustion chamber. In particular, the switching valve group and the thermal storage layer, which is fitted with the new ceramic technology, can be divided into multiple sectors, which alternately and cylindrically serve as the exhaust sector, intake sector, and a purge sector. Each sector is separately equipped with 3 valves: intake valve, exhaust valve, and purge valve. The functions of the sectors are changed by turning on and off valve switches. Take 5-sector RTO as an example. When Sector 2 acts as the intake sector, Sector 3 and 4 are exhaust sectors, and Sector 5 is the purge sector. When Sector 3 acts as the intake sector, Sectors 4 and 5 are exhaust sectors, and Sector 1 is the purge sector. When Sector 4 acts as the intake sector, Sector 5 and 1 are exhaust sectors, and Sector 2 is the purge sector. When Sector 5 acts as the intake sector, Sectors 1 and 2 are exhaust sectors, and Sector 3 is the purge sector. When Sector 1 acts as the intake sector, Sectors 2 and 3 are exhaust sectors, and Sector 4 is the purge sector. In this switching cycle, each sector plays the function of gas intake, purge, and exhaust in turn.